Hello, welcome to 5-6. Today we're going to be studying how to multiply fractions by whole numbers. Now, hopefully this will be another pretty easy lesson, hopefully pretty short. There's just one little trick we have to follow, and we'll get straight into that. Our goal today is that we will be able to multiply fractions by whole numbers. All right, let's try our first problem. 5 times 1/8. Now, here's the deal. We can look at this as, because multiplying is really repeated addition. So if I did 5 times 1/8, I could look at it as 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Right? Like if I had 2 times 3, I could look at it as 3 plus 3. Or 2 plus 2 plus 2. I have to add 3 2's or add 2 3's. We can look at it the same with fractions, because really fractions are just numbers, right? They look different, but they're really just a number. So I don't ever want you to get tripped up like, oh, well, I could do it if it was whole numbers, but I don't know how to do it if it's fractions. A lot of our rules apply. Only thing we have to remember is adding, subtracting. We need a common denominator. That's really the only trick, though. So if I added up 5 1/8, I'd get 5/8. Obviously, this is kind of a pain way to show it, so let me show you our shortcut. Not really a shortcut, but another way to look at it. So if I took the whole number 5 and I put it over 1, that means I have 5 pieces, and how many are in each pie? There's 1 in each pie, so I have 5 whole pies. I ate 5 pieces, and I cut each one. Each pie is whole, because there's 1 on the bottom. Yep, and I ate 5 of them. And then if I multiply that by 1/8, I'd multiply my numerators and get 5. And I'd multiply my denominators and get 8. Now, when we were adding and subtracting, we did nothing with the denominators. We left them alone. Well, now we multiply. When we multiply and divide, we have to do something with the denominator. We don't keep it the same. So in this case, we're multiplying by 1, so technically we kind of are. So 5/8 would be our answer. Again, we could show our work this way, which takes longer, or this way, which takes shorter. Let's pick the shorter way. Let's try another one. 3 times 1/9. So again, if I took 3 over 1 and I multiplied it by 1/9, I'd multiply my numerators. 3 times 1 would be 3. 1 times 9 would be 9. Then I better simplify. And you might say, oh, it didn't say to simplify. It might be a question on a test. But really the rule is always simplify unless they specify not to. So 3 divided by 3 would be 1. 9 divided by 3 would be 3. So our answer would be 1/3. Okay, let's try another one. 4 times 7/8. So again, I'm just going to put my 4 over 1. Times 7/8. Multiply my numerators, I'd get 28. Multiply my denominators, I'd get 8. 28 over 8. I could reduce. Let's reduce first. Divide by 2. Divide by 2. I can divide by 4. Let's divide by 4. So that'd be a lot easier. Then I'm not doing 2 simplification processes. I'm doing 1. Divide by 4, divide by 4, because 28 divided by 4 is 7. And 8 divided by 4 is, oh my gosh, 2. Okay, so how many 2's go into 4? 2, 4, 6, 3 2's, and there's 1 left over, so 3.5 would be my answer. I could also divide it out. 7 divided by 3, 3 goes into 7. 2. Top divided by the bottom. 2 goes in there 3 times, minus 6. I'm left with 1. Here's my numerator. Here's my denominator, 3.5. Now, 4 times 7/8. I want to talk about that another way. 4 times 7/8, which I'm sure a lot of you are going. So if I do this over 1, now here's what I can do. I can see that I have a 4 and I have an 8. So I can reduce before I multiply. And how I would do that And if this is completely, you're saying, Mrs. Hamer, I have no idea what you're talking about, that's fine. For those of you who are at this point, I'm just giving you another little tip. Okay, I can reduce before I multiply, so I'd look at 4, and I'd say, well, if I divided that by 4, and I divided this by 4, right, a numerator, denominator, that's what it's got to be. I couldn't simplify numerators, right, because when I simplify, I divide the top and the bottom, or the numerator and denominator, by the same number. So this works. I can cross that out and make it a 1, cross that out and make it a 2, and now I just get my 7/2, which is my answer, well, 3.5. So that way it is a little bit quicker. Let me try another one. 2/3 times, let's do 2, 9/6. So I have to do opposites, numerator and denominator, which I could already simplify that one, so that's not a very good example. Let me do 9, well, I'll just do 9/2. So I could divide by 2, divide by 2, and I would get 1, 1. And then I could divide by 3, divide by 3. Do you see I'm doing like diagonals? Those are the numbers we would simplify. So then this would cross off, make a 3. This would cross off, make a 1. So then my answer would be 1 times 3, or 3, and 1 times 1, or 1. So my answer would be 3. Whereas if we did it the other way, you guys, if I tried to do 2/3 times 9/2, I would do 2 times 9 and get 18, 3 times 2 and get 6, then I'd have to divide by 6, divide by 6, and I would get 3. So, I mean, if you see it, great. If you don't, do the other steps I taught you to. This just adds the second step of simplifying after or simplifying before, which when we're using smaller numbers is not a big deal, but if you're having to multiply large numbers, it's much better to simplify before. So then you're going to waste all your time multiplying these big numbers. Anyway, sorry for the rant. Let's go into another problem. So, evaluate 6x. So that's what we're going to start with. That's our problem, 6x. And we know that x equals 1/8. Okay, so instead of x, I'm going to put 1/8 in for x. And we know that this is showing multiplying. So I, again, would do 6 over 1 times 1 over 8. And I would get 6/8. Or I could reduce before. I could divide by 2. Divide by 2. And I know my answer is going to be 3/4. Or I could do it afterwards. Divide by 2. Divide by 2. And I would get 3/4 is my answer. Right, let's do another one. So again, I'm evaluating 6x, and I know that x is 2/3. So I do 6 over 1 times 2 over 3. Now I wanted to dispel a common error. I would not simplify this 6 and this 2. It has to be diagonal. So I could divide by 3, and I would get 2, and I would get 1. So I know my answer is going to be 2 times 2, which would be 4, over 1 times 1, or just 4, would be my answer for this one. And if we did 6 divided by 3, I'd get, yep, so 4 is our answer there. All right, let's try one more problem here quick. This next one's a word problem. This is supposed to have a 3/4. Any proposed amendment of the United States Constitution must be ratified or approved by 3/4 of the states. When the 13th Amendment abolishing slavery was proposed in 1865, there were 36 states. How many states needed to ratify this amendment in order for it to pass? All right, so we need to know what is 3/4 of 36. Whenever we see of, we think multiplying. So I do 3/4 times 36 over 1. So I'm going to, it's like this, you guys. I'd have to figure out what is 3 times 36. Or I know that 4 goes into 36. So I can divide by 4. Divide by 4. So I'd get 1. 36 divided by 4 would be 9. Now I'm doing 3 times 9 instead of 36 times 3, which that would be much trickier. So 3 times 9, I already know that is 27. So 27 states, I'm running out of room. 27 states were needed to ratify the amendment. All right, that's all that I have for you today. Thank you for watching, and we will practice this when we come into class tomorrow.